Welcome to Talk Talks, sponsored by the Tampa Amateur Radio Club. To learn more about our club, visit us online at www.hamclub.org. Or if you enjoyed this presentation, consider joining for only $35 per year. In this presentation, originally recorded on June 3, 2020, Lee Bullino, KX4TT, discusses 6 meters, aka the Magic Band.
Good evening. This is a presentation on 6 meters, also known as the Magic Band. This presentation was originally done the 19th of May, 2020 for the Tampa Amateur Radio Club. I am Lee Boulino, KX4TT, the presenter, and the agenda for tonight is to talk about the 50 megahertz 6 meter band. It really is the magic band for a number of reasons that we're going to get into. First of all, it's not called the magic band for nothing. This is a band that can be dead to the point where you can barely talk down the street one moment, and the next thing that can happen is you can have a Japanese station come through super loud wanting to work you. This can happen within a matter of a couple minutes, and then the band can go dead again. And it's due to this unexpected propagation. Another nice thing about 6 meters is that even if you have a technician class license, you can join in. You don't need to upgrade to a general. You don't need to have an extra. You don't need to have a whole bunch of years on the air to be able to participate in 6 meters. If you have an HF rig that was made in the last 10 to 15 years, it's highly probable that you're going to have 6 meter capability. If you don't have an HF rig, but you want to get on 6 meters, HF rigs now are very, very inexpensive, even new. And used, you can often have a rig that'll do 6 meters for $300, $400. Portable operation works really well for 6 meters because the antennas are small and they don't need to be up in the air a great deal. A 3-element beam at 20 feet or 25 feet at the end of a painter's extension pole will actually work for 6 meters and will allow you to get excellent propagation. Before World War II, we didn't have a 6 meter band. We had a 5 meter band, and that was due to the fact that every band, amateur band, was a multiple of 2 of the last. So we had 80, 40, 20, 10, and 5. There was no 15 meter band, and the 5 meter band was 56 to 64 megahertz. But after World War II, when television became a commercial entity, the FCC took it away. Television was a double-edged sword for hams on 6 meters. We lost 54 to 60 megahertz by channel. It got assigned to TV channel 2. 60 to 66 got assigned to TV channel 3. We got 50 to 54 megahertz in return. This is the double-edged sword. You could use channels 2 through 4 to detect band openings. If you were sitting at your house in Jacksonville and you were seeing the station in Daytona Beach, WESH, bright and clear on your TV, and better yet, you were seeing WSAV in Savannah, which was channel 3, or WEDU down over in St. Pete, which was channel 3, you knew you had a band opening on 6. But if you lived in an area where you had channel 2, especially, you had interference with TV sets. For those of us that spend a lot of quality time in the Orlando area, it's a miserable time. The good news is this is all gone now because analog TV is no more. We now have digital TV and cable systems. prior to the late 1980s was basically a hodgepodge of homebrew equipment, converters, transverters, with the occasional single or dual pan rig. While these rigs did have 6 meters, they often had the sensitivity of a drill instructor. They just weren't real sensitive. Selectivity was an issue with them also. So working DX with them was tricky. It was tricky. You would chase the other ham around the band a bit sometimes to make a QSO. But once the late 1980s appeared, 6 meters started to show up in modern solid state HF rigs. The Kenwood TS 680 and the ICOM 726. Now, they were about 20% more than rigs without 6 meters, even if the rig without 6 meters had an automatic tuner in it. They were still fine rigs, and they got many a new ham on 6 meters. And these are the rigs right here. The 680 is on the left, my left, maybe your right, depending on how you're looking at it, and the ICOM 726. Both are fine rigs. You very rarely see any today used. They just weren't sold a lot because the 725 and the 140, TS 140, which were the non 6 meter rigs, they sold a boatload of those. But 6 meters is real common now. It got easier to add because we were able to develop more broadband circuitry. We were able to develop transistors and FETs that had higher and higher unity gain measurements, which means that you had more gain available at 50 megahertz. So now even entry-level rigs, ICOM 7200, the Kenwood TS480, the Yaesu 450, the Yaesu 991 series, the ICOM 7300, all these rigs have 6 meter capability. But when you get up in price to the top end rigs, usually the front ends of them are a little bit less noisy and a little bit more stable. That stability is not usually too important unless you're doing high-speed digital modes or you're doing EME, Earth, Moon, Earth. Hold your questions on Earth, Moon, Earth. We're going to talk about that. And now we're going to talk about propagation, which is really the element that makes the 6 meter band magical. It does have HF-like propagation at times. Many times it has elements of 2 meter propagation. It's unique in this respect. Now, we're going to talk about polarization a little more later, but we're going to talk about horizontal versus vertical polarization in terms of the modes you operate and in terms of a penalty you pay for being cross-polarized. We're going to discuss that a little later. The ionosphere is simple. Layers much like an onion. The D layer, which tends to attenuate signals. The E and F layers are what we get excited about, especially the E layer with 6 meters. The sporadic E propagation is the most common way of working DX on 6 meters or working states far away, like Washington and Wyoming, which I happen to work today. The F layer, when you get F layer propagation, you have been living cleanly because the propagation gods have said you are deserving. Because F layer propagation can bounce your signal literally halfway around the world. It doesn't happen often on 6 meters. When it does, you need to be on the air. Sporadic E, like I mentioned this a minute ago, most common. Basically, you need to realize that the atmosphere is not just one layer of air molecules. There are ionized charges within the atmosphere. And when you have regions of them that are more dense in the surrounding space, you have the potential for sporadic E propagation. The clouds may be these clouds, these regions may only be a few feet in diameter, or they may be the size of battleships, or they may be hundreds of miles in diameter. It's basically an RF mirror. You ever take a flashlight and you point it at a mirror and you watch it bounce off the mirror? Well, these regions act as an RF mirror up to the maximum usable frequency for the area affected by the cloud. Contacts can happen up to 2,000 miles. You notice that there's a comment there about forward and back scatter. Forward scatter is very simple. You point your antenna at a region of ionized particles. You bounce your signal off this region and it bounces the signal further. So you may work somebody 2,000 miles away due to a region of ionization 1,000 miles away. You can also get backscatter where your signal ends up going back behind you and back at you, which means although the region of clouds that say is 1,000 miles away, you end up working somebody 200 miles away. This tends to be a daylight phenomenon, but sometimes we even have it happen at night. The other night, Europe was going great guns, and it was probably due to real specific sporadic E. Some hams that night in the U.S. got to participate and actually do multi-hop sporadic E. We're going to talk about that in a second. You can even get sporadic E on 2 meters. It's a lot more rare. The requirements are a little bit more stringent for that to happen. Multi-hop, like I said, multiple hops along various E and F layers and back down. Water is very helpful in that it acts as a mirror too to RF. So if you all of a sudden are sitting there on 50, 125, just monitoring, and all of a sudden you hear somebody with a British accent and a British call sign, and it turns out he's sitting in Great Britain, that's probably double hop, 2 E hops to the UK. An F2 hop, one F2 hop can also do the same thing, but like I said, those are a lot more rare. Triple hop propagation can also happen. We saw some triple hop propagation between the US and the EU in 2018, which allowed hams, including myself, to work stations like in Crete, Greece, Albania, and other areas like that, Lithuania, Lebanon, Kuwait. It's quite rare. And when it does happen, get really excited because it means that you're going to have some pretty good QSOs. Transequatorial propagation. This is north-south propagation. And as you might suspect, it involves the equator. Think about this. What portion of the planet does the sun tend to shine on the most? The equatorial regions. Since those areas get a lot of solar radiation, they also can get quite ionized, and the ionosphere can be denser. So you can have north-south propagation. This north-south propagation can extend quite far in both directions, which would allow you to make a contact from Florida to, say, Suriname or Brazil or Venezuela. And we had some of this happen Saturday. I made contacts with Colombia and Venezuela, Trinidad and Tobago, Bonaire, and Aruba, and St. Lucia. And probably, given the time of day, it was transequatorial propagation. The high sunspot number during the solar maxima helps, but you can still have TEQ during solar minima. It's just less frequent. So if you all of a sudden get north-south propagation going and you're hearing stations in South America or in the Caribbean that are quite a distance away, like Trinidad, Tobago, Barbados, Curacao, Bonaire, Aruba, that may be very well what's happening. You usually see this about 1500 to 1900 local, not Zulu time, local time, late in the afternoon. Then we have auroral propagation. It's caused by magnetic storms. Auroral propagation is no fun for HF communications, but if you can point your antenna at the right spot at the right time, you can get some interesting QSOs with it. CW is your friend because voice communication is tough copy, has this buzzy sound in the background. Not a lot of fun. MSK 144, which is one of the modes that WSJTX has, is a useful mode for this also. I strongly suspect FT4, since it has such a short cycle time, is probably useful here. But MSK 144 and CW are going to be the primary modes. Guys, learning CW even at 5 words a minute can help you, not only with auroral propagation, but with some other things that we're going to talk about later on. So that's my public service announcement for learning CW, even at a slow speed. It will help you on VHF. Scatter. We talked about sporadic scatter, which is basically sporadic E propagation is a type of scatter. It sends your signal in several directions. The auroras do. But you're bouncing a signal off of things is what you're doing with scatter. You can do it with a meteor. You can do it with a thunderhead. And a thunderhead is really highly charged. So you can bounce your signal off oncoming thunderhead. Just make sure that before the lightning gets there that you have shut your station down. You can also bounce a signal off the rear end of an aircraft. Now, when somebody got on our email group on our reflector and said that they were doing that, you would have thought that he had kicked the dog and had scalded the cat and had spanked all his kids, and that he had put all these people's lives in that aircraft in danger. Guys, I'm going to point something out to you. A 6 meter, 100 watt signal is not going to hurt an aircraft. An aircraft lives in a pool of RF. Airports have so many radios and radars going on, so the energy from a 6 meter signal is not going to matter to an aircraft. So what you do is point your antenna at the end of the runway at Tampa International. Listen to the air traffic control. When they take off, start sending FT8 or start sending CW, and you'd be surprised at what you can get. Now we talked about forward and back scatter a minute ago, and it's the same thing here. Is if the signal bounces off whatever you're pointing it at and goes further in the same plane or in a different plane but further along, that's forward scatter. If it comes back towards you, that's back scatter. You can actually with back scatter be point your antenna northeast and end up having a conversation with a station in Ohio because you're bouncing it off a cloud or off a thunderhead or a meteor shower, and it's bouncing backwards. Very simple. Earth, moon, earth. You really want to have some fun? Bounce signals off the moon. You're going to have some power, though. 1,000 to 1,500 watts is really what you need. Your receive antennas must be efficient. Can you do it with a single Yagi? Yeah, if you have a 5 or 6 element Yagi and the other station has good ears and you're running 1,000 watts, yeah, EME is possible. What you try to do is right around sunset, point your antenna slightly southeast where the moon comes up, and send a CQ using JT65A mode. If you're not familiar with JT65, learn about it. You need to learn the rules for Earth, Moon, Earth, but once you know the rules, you can have a lot of fun. If you want to build your own Earth, Moon, Earth station, just recognize you're going to need an amplifier that'll put out some serious power, and you probably want to have a 4 Yagi setup with an azimuth and elevation rotator. You know, but you might want to try it without one, just see if you can get with just the amp, see if you can get heard. You can also try this at sunrise, same deal. As the moon's going down, just before it goes down, try sending JT65 signals at high power, and you might be surprised at what you hear. Notice something about all this. You either have to have an area of highly charged particles or a large reflective surface. So E-skip, F-skip, aurora, thunderheads, meteors, you're not actually bouncing signals off a meteor, you're bouncing it off the tail, because the tail is ionized particles. That's your dense area, highly charged particles. But a large surface can also work. The moon, aircraft, possibly off the top of a tall building. The only way you'll know whether that'll work is to actually try it. Maybe off the mountain peak. Sometimes that works with 2 meters also, but when 2 meters, it's usually a little different. Tropospheric ducting. This is not reflective. It is refractive. The signals are bent. You usually have this happen where you have temperature inversions. Often it happens on mountaintops where the signals are bent as they go over mountaintop. It also occurs in coastal areas like Florida. And you can get interesting stuff. If you all of a sudden start hearing the FM station 101, 104.1 up in Tallahassee on your radio here, that's what you got. Then you want to try 50, and you want to try 2 meters too. Try 2 meters at that time. You can probably get some really good stuff. Polar propagation also seems to be refractive and tunneling. Could be similar to tropospheric ducting. Right now, we're not sure how it works, but when it works, it's phenomenal. One area of suspicion is that it may be due to ice crystals forming in polar regions, and either a bilayer with a tunneling phenomena, or it could be a case of where signals are hitting these ice crystals as ordinary scatter. But contacts can be had for thousands of miles. People have worked Japan from Florida on 6 meters over the pole. We just don't know a lot about this yet, but we're developing data, and hopefully in a later edition of this presentation, I'm going to talk more about polar propagation. And here we go, horizontal versus vertical polarization. You saw where I noted that there's a penalty to pay for cross polarization. Horizontal for every mode except FM. Vertical polarization for FM voice. There is a penalty, but it can be severe, but oftentimes it's not. And the reason for this is, first of all, there's no signal that is a perfectly horizontally polarized signal or a perfectly vertically polarized signal. And when you are bouncing signals off of areas of dense particle charge or big objects such as aircraft. The plane of polarization of the signal also changes. So it means that you can still be heard even if you're using a vertical antenna on FT8. Use what you got. But if you can only have one antenna, a horizontally polarized antenna will probably get you better results. And my definition of better results is more QSOs in your log. So is DX open? Finding out. dxmaps.com is really cool. You can actually see reported QSO. It looks crazy, like pickup sticks when it's really busy. And you really get excited when you see stuff from Florida going to Europe or going to Japan or going to South America, because then you know that the propagation is good for you. It can show any band from 2,200 meters to the microwave bands. Really good. Hamspots.net. You can sort by band mode, show 2 or 3 bands, and you can send out an FTA CQ and you can see who hears you. Speaking about hearing, you can also listen to beacons between 50.060 and 50.080. The beacons transmit in CW at 5 words a minute. So again, knowing CW, even at 5 words a minute, pretty good idea because you can tune, move your antenna, and listen. And you pick up a beacon, write down the call sign, because it'll be a call sign slash da 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 da, and then B for beacon. So it'll be da 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 da. Listen for it, write it down. We have list beacons available on the internet. Look up the beacon, you can see where it is, and you can see usually how much power they're running on what kind of antenna. PSK reporter, very much like DX maps. You send out your signal on FT8 and you see where you're heard. FM radio is great because if you hear stations that normally you don't expect, I mentioned 104.1 up in Tallahassee. If it's breaking through the local 104.1, you got some propagation going on that may be good for 6 and or 2 meters. So check it all out. What can you do on 6 meters? Same stuff you do on any other band. Chase DX, collect grid squares. You can get DXCC on 6 meters, but you can also get another award called the VUCC Award for working stations in 100 Maidenhead grids. For instance, the Tampa Amateur Radio Club clubhouse is in EL88. In fact, EL88, the border between EL88 and EL87 starts right about Hillsborough Avenue. So Tampa ARC clubhouse is in EL88. But some of us guys that live down in South Tampa, we're EL87. Got buddies over in Lakeland. Some of them are going to be EL98. Some of them are going to be EL97. Some of them are going to be EL88. And some of them are going to be EL87. The point for those 4 grids is in Southwest Lakeland. So you can collect grids. I've worked over 300 grids. Every time I get a new grid, it's pretty exciting. Every time I get a new one on DXCC for 6 meters, it's real exciting. And you can get quite a few stations with just a minimum of work if you're smart about knowing your propagation. You can do contesting, so you could do VHF contesting. The ARRL Summer VHF contest, it's the 3rd week of June. It's a real popular one. You can rag chew the digital modes. FT8 is usually 50.313, 5313, but also 5323 if the band Europe is going crazy. The Europeans will move up 10 kilocycles. So you can go up there and work them. You just got to be paying attention. Nets, the Brandon Amateur Radio Society has a 6 meter net every Tuesday at 7 p.m. locally on 5200 kilohertz. So getting on 6 meters, what are you going to need? You need to have a rig. It's got to be either an HF rig or a VHF rig with 6 meter capability. And if you really want to have fun on 6 meters, you really want multi-mode capability. So you really are probably going to get an HF rig. The ICOM 7300 is a really good deal for a 6 meter rig. The Yaesu FT991 is a good rig. The ICOM 7100 is a good rig. And these rigs are not really expensive. Used rigs like the ICOM 706 series, the 7000, the Yaesu 857, and other rigs have 6 meters. You know, the 746 and 746 Pro are an especially good deal because they not only have 100 watts on 6 meters, they have 100 watts on 2 meters also. So I have an ICOM 746. It's a good rig. If you can find an ICOM 746 at a reasonable price, that might be a rig for you to consider. There are some single band rigs that are rare. Usually the people that are selling them know that they're rare, and they'll want you to pay as much money for the single band rig as you could pay for a full HF rig that gives you 160 through 6 or even 2 and 70 centimeters. Be aware of that. Transverters. Q5 signals in Elecraft have transverters, but if you're a newbie to transverters and you don't interface it correctly, you will release the magic smoke. And sometimes it can be mighty exciting for both the transverter and your rig. So if you're going to do a transverter, make sure you have the timing circuitry that shuts down your transmit, turns on your receive before it kicks the converter in, and does everything properly timed, or you will have problems. Let's talk about antennas. If the band's open, even a dipole, and a dipole in 6 meters, by the way, is about 10, 11 feet long, really short. A small Yagi beam, you can buy them new for less than 200 bucks, and you can get 4 elements, 3-4 elements less than 200 bucks. TV rotator, you know, the old TV rotators will tune them. If you want to do Armstrong, you know, where you tune it with, turn it with your arm, and you're going to do portable, get a painter's pole and you can hang it on a painter's pole at about 20 feet. It'll work fine. If you want to get them higher and stack them, you can do that. The stacking distance usually is about 12 to 14 feet. So you could have one at 40 feet and another at 26 feet. However, you need to model it before you stack it, so that way you know what propagation and what performance to expect. When you're stacking antennas, you need to do some legwork beforehand. Otherwise, it will be an expensive mistake. Horizontal, again, horizontal propagation for everything but FM voice. I mentioned that cross polarization penalty. You'll have some books say it's 20 dB. You know, of course, I've got a one-word answer for that that begins with bull. It's a penalty. It's variable. It can be 20 dB. A lot of times it's not. So use the antenna you got, such as this Yagi. That's a 4-element. I think that is I think Arrow Antennas makes that. And it's like $170. 4 elements. And that one's the elements are solid. So there's no tubing that can get easily bent. See, so that will do you well. For if you want a little bit more gain and you're willing to pay a little bit more coin, 5, 6, 7, you can get an 11 element Yagi on 6 meters if you want to. You just have to have enough tower to be able to put it up. If you really want portable, that is a Moxon or Moxon antenna, however you want to say it. It is basically a 2-element folded beam. This one's made by Power Electronics, Dale Parfit, up there in North Carolina. I own one of these for some of my portable work. It is an excellent antenna, and that weighs 1.5 pounds. 2 elements, you can put it on a painter's pole. From the time, it takes less than 5 minutes to put it together and less than 3 minutes to get it up in the air. So you can be in a park operating within 10 minutes of pulling up. This is a halo antenna. It is also a horizontal polarized antenna, and it's omnidirectional. It has a little bit less gain than a dipole, but it is omnidirectional. You don't have the lobes on the end of the dipole where you can lose stuff. And a squalo antenna is also pretty much omnidirectional. If you look, it's actually not quite omnidirectional. It's squished a little bit, but it'll also work. That looks like a homebrew one made with copper plumbing pipe, so it looks like a plumber's nightmare. There is a triangular antenna called the Omni-Angle. Again, Dale at Power Electronics makes that also is fairly omnidirectional. And they all have, like I said, about the same gain as a dipole, within 1 dB or so. Now, if you're going to go FM, there's your vertical ground plane antenna. Very simple. You've got the radiating elements in the center, and then you've got 4 counterpoise elements. J-pole is also a vertical antenna, and you can scale a J-pole for 6 meters. It'll be approximately 3 times the size of a 2-meter J-pole. So if you have the plans for a 2-meter J-pole, multiply everything by 3, and it gives you the tubing sizes you need. A disc cone is also a vertical antenna with a whole bunch of elements of different lengths at the bottom in order to allow for radiation. You lose what you gain with a disc cone is these are wide range antennas. A lot of them can cover 10 meters all the way up to 23 centimeters, but it's kind of a jack of all trades antenna, but not necessarily a master of any one band. Horizontal, vertical polarity, the quad. The quad, if you feed it at the bottom or the top, is polarized horizontally. If you feed it on the sides, it's polarized vertically. You can actually build a switching mechanism to allow you to switch between polarizations. Quad design can be tricky from a standpoint of the mechanics of it, but 6-meter quads are not that big. 2-meter quads are not that big. If you're talking about a 40-meter quad, that's going to be big. But a 2-element 6-meter quad will give you wide bandwidth and can provide excellent service even in Florida weather if you do the mechanics correctly. So building, like I said, a 2-element quad or a small Yagi, they're fairly easy builds. You got to remember that for a 3-element Yagi, you only need about 30 feet of tubing total. You can use pipe fittings to connect tubing and stuff like that. A horizontal loop or a halo can be made from a lawn chair. Makes a good beacon antenna. J-pole, I mentioned that earlier. It's a pretty easy beacon antenna to build. It'll vertically polarized, but like I said, you don't always lose a whole lot by cross polarization. But you do need to use the best coax you can afford. Bad coax can turn a multi-$1,000 rig into a $300 radio. And yes, that is an actual Biff Crane quote from February 2018 at a steakhouse. He did not open his mouth during bites to say this. This was before we got our steaks. If you're going to run lower power, less than 500 watts, LMR 240 is great. It is not that expensive. It is very flexible, and it is a very low loss coax. If you're going to run higher power, you got to use LM400, even LM600 if it's a long run. You know, for more than 100 feet, LM400 no matter what, just simply because you're going to lose a lot of power in the coax if the run's long enough. Preamps are a double-edged sword. While they can help you if you have an older rig that maybe is not as sensitive as you would like, newer rigs, it'll often hurt by degrading the dynamic range of the rig. Another thing about preamps is you have to have either timing inside the preamp where it can detect your RF and quickly switch it out of the transmit line, or you have to run cabling up to it to flip the timing on it, so that way you're not transmitting through your preamp, or you're bypassing the preamp. We don't want to let the magic smoke out. Antenna location on towers is important, in that you don't want to have a 6-meter antenna 2 feet away from a 3-element 40-meter beam. You lose some capture area when you do that. You do not have to have your 6-meter antenna way at the top of the tower. In fact, you might benefit more from having the 6-meter antenna down on the tower a bit, and so your HF antenna is higher up on the tower and gets better performance. Again, you got to do some antenna modeling, and you have to do some legwork before you start putting stuff on the tower. Otherwise, it's going to be an expensive proposition that could lead to poor performance and leave you unhappy. Sources of information. The UK 6-meter group is really good. They publish a newsletter 4 times a year. I think it's $10 a year to join. It's really inexpensive. The ARRL website has buku information on all aspects of 6 meters, including a column called The World Above 50 Megahertz that is required reading every month for those people interested in 6 meters. DX Maps, that's the website that can show you who's hearing who, and it does it in a graphical way. W7GJ Lance, you want to learn about 6-meter Earth, Moon, Earth? He's the guy. W3EP, another guy that you can learn a lot from. The same thing with K16 and WA5POK. Books. The handbook has sections on VHF. The antenna books have sections on 6 meters. And remember, you can look at 2-meter and 10-meter antennas and can scale them. There are books on VHF from our friendly hams over in Great Britain, Radio Society of Great Britain. They have books on VHF, including 6 and 4 meters. Again, a 4-meter antenna can be scaled up to 6 meters. The ARRL Technical Information Service. If you are an ARRL member, one thing that your $49 a year is going to is to have a bunch of really smart engineers in Newington, Connecticut, whose job it is to answer your questions. And they can be a simple question such as, how long do I need to cut a dipole for 6 meters, to something as complex as, I don't know whether I should place a 6-meter antenna 55 feet on my tower or 40 feet on my tower. They can help you with the modeling for that. They're not going to do it for you, but they can give you some guidance. You want to take advantage of them if you're an ARR member, because your money's paying for them. I do have some people to thank. Dave Birnbaum and Brian Fields were very helpful with describing some of the propagation, and especially with some of the calculations involving cross-polarization, because I had suspicions that the authoritative number of 20 dB was kind of a red herring. I brought it up with Dave and Brian, and I got pretty much the same answer from both of them. Brian's was just a little bit more colorful. Lou, you want to learn about propagation on HF bands? Lou Romero is the guy to talk to. He does a really great presentation on propagation. If we don't have a recording of it, we should get one. Biff, Biff for just some good comments, and the fact that Biff really does also understand 6 meters. He's operated it long enough. Lance is the guy for Earth, Moon, Earth. Dan Street lives down in Sarasota. Dan's a sharp cookie. He's won more contests than you can shake a stick at. And he knows towers too. He is a tower climber in rigor. K1SIX, Lance W7GJ gave me a lot of good background information. And Kai, KE4PT, is a professor of engineering at Ford Atlantic. He and I had a couple of very interesting conversations involving 6 meter polar propagation. If you can go see a lecture by Kai on propagation or on RFI and eliminating RFI, take the time to do it. You will learn stuff and it will help you get more QSOs in your log. If anybody has questions about this presentation, I can be reached at kx4tt@yahoo.com. Just simply let me know in the subject that it involves my 6 meter presentation and your question. If I do not have an answer to it, I will know somebody who probably does, and I may very well get them involved. I appreciate you listening to this presentation, and I want to extend my thanks to the Tampa Amateur Radio Club for providing the facilities to allow me to present this information and for providing the facilities that allow me to make a lot of great QSOs on 6 meters. Thanks a lot and have a good evening, all.